In this video, we will talk about Quantile Quantile Plot and show how to plot a normal Quantile Quantile Plot in Python. So first, we will show what is a quantile. So quantile of a sample, or called QF, actually is a value for which a specified fraction f of the data values is less than or equal to QF. So quantile Q actually is a random number, is the value of the random number from the observation. And it is related to a fraction called f, or called the cumulative probability. So the fraction of the observation in this data set is less than this quantile number. So we call this is a quantile of f. So if we let the order of the observations, so from 1, 2, 3, 4, for example, to the 20, ranked from the low to the high value of the number associated with 1, 2, 3, 4, 20, right? And the fraction can be calculated as I minus 3 of 8 divided by n plus 1 of 4. So this fi number for each observation is between 0 and 1. And this number is also increase with the I number, right? So what is the quantile of the normal random variable? So if we have the fraction number from 0 to 0.1, 0.2, and so on to 1, this represents the cumulative probability, or the fraction of the observations, a fraction of the random numbers. Then a normal distributions random variable quantile is from this formula. So mu and sigma are the mean and standard deviation from this normal distribution. So we just fill in the proportion or the fraction of the data, then we can calculate the quantile random number associated with this normal distribution. So if it is a standard normal distribution with mean 0 and standard deviation 1, so its quantile number associated with the fraction can be calculated with this formula. Actually, both of the formulas are approximation, but very close to the real number. So next, we can connect the normal quantile and the sample quantile using normal Quantile Quantile Plot. So if we have the sample quantile, fi from this I represents the order of the sample, n means the sample size. So we can calculate this fi. Then next we can fill this fi into the normal quantile formula. For example, for the standard normal distribution with 0 and 1, so we can get the Q01 fi. So next we can plot in x and y axis, representing x-axis representing the normal quantile value, and the y-axis represents the sample observations for each observation associated with I. So if the plot shows a nearly straight line relationship between those two, so we can suggest or conclude that the data come from a normal distribution. So in Python, if we want to plot a normal Quantile plot, so we can import stats models API submodule called SM. Then we can also import matplotlib. Then can use SM. Actually, SM is the API model, right? So use sm.qqplot with the data. Data is the sample data. So this means default setting is we want to plot a sample data against a normal distribution. So next we will show two examples in Python. So first we import these libraries, NumPy and stats module API and matplotlib. So in first example, we generate random numbers from normal distribution. So we use np.random.normal with the mean is 6, standard deviation 2, which we draw 100 such random numbers. So we can use sm.qqplot with these data points, and we also add a line with a standardized line in the plot. So it looks quite informative that the data almost stay on the lines. So from this figure we can say data comes from a normal distribution. Although the values also can show that it is not a standard normal distribution, as the mean value around here, right? So this x-axis is called theoretical quantiles. It means the standard normal distribution between -2 to the 2 and the sample data between about 1 to 12. So in the next example, we show first we draw some random numbers from logistic distribution with the default setting, and also just 100 such random numbers. Then, same as before, we also plot with the qqplot for this dataset and add a standard line in the plot. So you can see here, because data is quite random, but in the lower part and upper parts, they're like S shape. So it is very difficult to say that it's come from normal. Although in the middle part, quite close to the straight line, but in the both ends of the data, it does not look like a normal. So it is quite skeptical that the data from a normal distribution. So because this is random numbers, if we run again, every time is different. So you can see this shape also S-shaped, right? So it is skeptical that this data from normal distribution. Now, of course, the QQ or Quantile plot, normal Quantile plot is only provide assisting diagnostic visualization to check if it is from a normal distribution. So we will also use some formal tests, for example, Shapiro-Wilk tests for normality to get the numeric significance level to do decision making if its data is from normal. Anyway, the qqplot will help us to visually check if it is from normal distribution. Or qqplot can check from any distribution if we set options for the theoretical quantiles from other distributions than normal, right? Thanks for watching.